Have you ever admired the strength and elegance of titanium? This remarkable metal has made its way everywhere, from aerospace to medicine to luxury watches. But how is titanium produced, and what makes it so special? Let's dive into the fascinating process that transforms a raw ore into a versatile material used in so many modern fields. Welcome to the story of simple things, where we explore the fascinating past of those details that shape our world. And if you enjoy this video, remember to subscribe and activate the bell to support the channel. It gives us the strength to create even more captivating content. Titanium is not found ready to use. It is extracted from the earth as ore, mainly in two minerals, ilmenite and rutile, usually from open-pit mines. Australia, South Africa, and Canada are among the largest producers. Extraction requires heavy machinery, followed by crushing and washing to separate titanium-containing minerals from other matter. Titanium is the ninth most abundant element in Earth's crust, but rarely found in pure form because it bonds easily with oxygen and other elements, trapping it in chemical compounds. Extracting pure titanium requires a complex, multi-step process. The most widely used method is the Kroll process, developed in the 1940s by William J. Kroll. It begins by transforming the ore into titanium tetrachloride, a highly reactive liquid. The ore is mixed with chlorine and a carbon source such as coke, then heated to around 1000 degrees Celsius in a reactor, causing the chemical reaction that forms titanium tetrachloride, with impurities remaining as solids. This liquid is then distilled to be purified, then reduced with magnesium or sodium in an inert atmosphere, producing titanium sponge, a porous metal ready for refining. This sponge is melted under vacuum or electron beam. It is often mixed with aluminum or vanadium, then cast into ingots, forged or rolled into sheets, bars, or tubes. Titanium, aluminum, vanadium alloys are highly valued in aerospace and automotive industries, thanks to their strength, lightweight, and corrosion resistance. Titanium is machined with special tools, and can be polished or treated depending on its purpose, whether in medical implants or aircraft parts. Its production has an environmental impact, but its durability and recyclability partly offset this. Greener processes, such as FFC Cambridge, are being researched. All this effort is worthwhile because titanium is strong, light, corrosion-resistant, and able to withstand extreme temperatures. Perfect for
aircraft, rockets, implants, and high performance.
Sports gear. Its natural beauty and ability to form colorful patinas make it a favorite in jewelry and luxury goods. Titanium is more than just a metal. It is a symbol of what science and technology can achieve, and will likely play an even greater role in the future. Next time you see a titanium
Object. Remember the extraordinary journey it
took from deep within the earth to the
technology of tomorrow.